In this video, we're going to talk about how we evaluate radical functions. We're going to continue on in section 9.1. So we're just going to take our radical functions and we're going to evaluate them like we've been evaluating other functions. So f of 3 here is we're going to plug in 3 wherever we see an x. So this becomes the square root of 12 minus 3, which is the square root of 9, which is just 3. Remember, we're looking at the principal square root here. Similarly, if we're going to do f of negative 6, what I'm going to do is plug in negative 6 wherever I see an x. So this gives me the square root of negative 24 minus 3, which gives me the square root of negative 27, which is a problem because this is not a real number. Okay, and again, we've talked, we will learn how to deal with square roots of negative numbers, just not yet. Okay, so let's take a look at this one. It says the period of a pendulum, that is the time required for the pendulum to swing back and forth one complete cycle. And here it gives us this function, and it says find the period of the pendulum that is 4 feet long. Okay, so what I'm going to do is I'm going to say, okay, well, what is f of 4? Oops, that's not a very good 4. F of 4. Well, that is equal to 2 times pi times the square root of 4 over 32. Which just gives me 2 times pi times the square root of 1 over 8, which you can take the square root of 1 over 8. In fact, now that I've thought about this a little more, we don't know exactly what that is just yet, okay? But that's okay. You will learn about how we're going to simplify those coming up in the near future. If it were 1 over 4, we could, let's just pretend for a second that this was f of 8 instead of 4. Then I would have 2 pi times 8 over 32 square root, which would give me 2 pi times the square root of 1/4. And we know the square root of 1 is 1 and the square root of 4 is 2, so that would be 2 pi times 1/2, which would eventually just give us pi. So we could simplify this. We're not quite there yet in our learning, but we're going to get there pretty soon. So you can just see, depending on how long this pendulum is, tells us how far it's going to swing. Okay? All right. Now the next thing I want you to start thinking about is perfect cube numbers, right? So we talked about perfect square numbers not long ago. Now we're going to talk about perfect cube numbers. Interestingly enough, with perfect square numbers, they always ended up being positive. And if you're starting with a positive number, your perfect cube numbers will also be positive. But we can also say, what happens when we cube a negative number? Well, negative 1 times negative 1 times negative 1, that gives us negative 1. Similarly, what happens when we cube negative 2? Well, negative 2 times negative 2 is positive 4, but when I multiply times negative 2, I'm now back to negative 8. And you can see where I'm going here. And so what I'm trying to help you understand is that with a perfect cube number, they could be positive or negative, whereas with perfect square numbers, they were always positive, because when I square a negative number, it turns it positive again. So we say if b to the third equals a, then b is the cube root of a, and it's positive or negative depending on what we're taking the cube root of. So example, cube root 125, that's just 5. But if I'm taking the cube root of negative 8 over 1,331, well, what is the cube root of negative 8? Well, that's negative 2. And then what's the cube root of 1,331? It's not on our chart, but if I give you a second, you should be able to figure it out. That's right, it is 11. So the cube root of negative 8 over 1,331 is the same as negative 2 over 11. And then again, I don't want you to forget how to evaluate functions. So in this case, f of 5, I'm going to plug in a 5 wherever I see an x. So 5 times 5 plus 2 gives me the cube root of 27, which is just 3. Okay? So start putting those perfect cube numbers into your memory, because again, we're going to need those when we're simplifying radical expressions in the future. Okay? Keep up the good work. We'll see you in the next video.